All right, we're gonna work on solving equations here. So here's a review. If you guys copy this down and work through it with me in your notes, you're gonna be able to use your notes on your test. So if you wanna draw this in your notes and then write down, follow along with me how I'm simplifying the equation to solve for x, that would be really helpful when you get to test time. So let's start by writing the equation for both sides. So I'm going to start writing it over here. So we've got 3x's and plus 3. We've got a minus 1. And then on the other side, or in the other region, we go to the other side, but the bottom, we've got the opposite of, and then we want to use parentheses, remember, 3x minus an x plus a 1, and then minus 2. And then that's set equal to the other side where we have 2x's plus 2 minus 1. Go down to the negative region, or the opposite region. So we'll say, and then the opposite of a positive x minus 2x's plus 2. So let's start simplifying. So I'm going to remove a zero pair. We usually want to start just looking in the same region and seeing what's opposite. So here we have opposites here that would make a zero pair. So we've got a 1 and a negative 1. And I'm actually going to go throughout and do that. So also here we've got a 1 and a negative 1. And then here we've got a 1 and a negative 1. And then when I go back through again, I'm going to also look for maybe if there are opposites with x's. So not up here, there is here. X and negative x make a zero pair. There's no opposites in this region, and then there is an opposite to make a zero pair in this region. Okay, so what we did was simplify here by using zero pairs in the same region. So now I'm going to rewrite my equation and just show that I simplified it a little bit. So in the top, we have 3x plus 2. And then on the bottom, we have the opposite of 2x minus 1. And that's equal to 2x plus 1. And then the opposite of negative x plus 2. Okay, now I want to go through and I'm going to look across to opposite regions. And remember, when we look at opposite regions, we can remove like tiles because this is a positive and this is a negative. So I see like tiles here, so I'm going to remove an x and an x, and I'm going to look across here and remove an x and an x. Nothing else when I look across for opposite regions can be removed. So let's come to the other side. And then I'm going to look across again, and I don't see any x's that can be removed. However, I do see a positive 1 and a positive 1. So I'm going to remove those. And now I am going to rewrite my equation again, and I am left with x plus 2 minus the opposite of 1 equals 2x, and then the opposite of negative x plus 1. And then we can look across. Actually, what we want to do next is, before we start comparing things, let's get all of our tiles into the positive region so we can distribute that negative right there. So remember, when we move it across the line, we can flip it over, move it across the line, flip it over, and then move it across the line and flip it over. So let's show what our new equation is. We've got x plus 3 equals 3x minus 1. And if you look, it's getting a lot simpler here, and it's looking a lot better and getting smaller as we go down as we keep simplifying. So our last step that we want to do is look across and see what does each equation, or each side of the equation, have in common. Well, they both have a positive x. So we can remove a positive x and a positive x. So rewrite now, we have 3, because we just have 3 left on this side, equals 2x minus 1. And then remember, we want all of our x's to be alone on one side and all of our 1's to be on the other side. So the x's want to be by themselves. So what's in our way? We have a -1. And if we want to get rid of a -1, we need to make it a 0 pair. So by adding a 1, we can make that a 0 pair. But if we add 1 to that side, we got to be fair and give this side a 1. And so I am now going to remove this 0 pair. In my equation, I can show that I added 1 here and I added 1 here. And now I have 4 equals 2x, because when I have a -1 and a +1, that's going to make a 0 pair. So then my last thing I want to do is just separate my x's, and I've got 2 x's, and then each x gets a 1 and then gets another 1. So when we look at 1x here, we can say that 1x is going to be equal to 2. So we have 2 equals x, or x equals 2. That would be the same thing.